Okay, so this is one of our homework problems, and the idea was to solve for C in this problem. So before we do this, we have to know we have fractions where our variable is in the denominator. In this case, it's C. We want to solve for C, but when the variable is in the denominator, as you have with rational expressions, you have to make sure the denominator is never 0. So 1 minus C can never be 0. 1 plus C can never be 0. And 1 minus C squared can never be 0. So what we're going to do, we're going to say, well, if 1 plus C were 0, right, and solving for C, we have C equals -1. This is equivalent to C being -1. So if C plus 1 is not allowed to be 0, C is not allowed to be -1. So we know that C cannot be equal to -1. And for our next denominator, 1 minus C, well, 1 minus C cannot be 0 because then we would have C divided by 0, right? We would have C divided by 0 over here. So we're going to say, well, C minus 1 being 0, if we solve for C, is equivalent to C being 1. So we know that C cannot be 1 because if C were 1, this is equivalent to 1 minus C being 0, and then we would have C divided by 0. And you can see that's true if you plug in C equals 1 here. Denominator, you have 1 minus 1 is 0, and you're dividing by 0, which you can't do. And for our last one, we're going to say 1 minus C squared is equal to 0. Well, 1 minus C squared equals 0. If I factor that, same as 1 squared minus C squared equals 0. Which is difference of squares, which is the same as saying 1 minus C times 1 plus C is equal to 0. Well, whenever you have the product of two numbers, or in this case it's two parentheses, which is just two numbers, is equal to 0, that means either this parenthesis equals 0 or this parenthesis equals 0, right? Because whenever you multiply two things together and they equal 0, it means one of them is 0. So that means 1 minus C is equal to 0, or 1 plus C equals 0. Well, the first one implies that C is equal to 1. So this tells us C cannot be equal to 1, but we already knew that. And the second one tells us C is equal to -1, so that means C cannot equal -1. Because if C were equal to -1, then 1 plus C equal to 0. Then 1 minus C squared would be 0, and we'd be dividing by 0. So the moral of the story is when you're doing rational expressions, take each of the denominators, set them equal to 0, solve for C, so we get C equals -1, C equals 1, and C equals 1 and C equals -1 for the down one. Now this tells you exactly what C cannot be, because that's equivalent to 1 plus C being 0, which you can't have, 1 minus C being 0, which you can't have, and of course this told us nothing new, right? So it just tells us C cannot be -1 and C cannot be 1. Now we're ready for the next part. We're ready to start solving. Before we start solving, we had to make sure we excluded certain numbers for our answers. So what we're going to do now is we want to find an expression that is divisible by 1 minus C squared, 1 minus C, and 1 plus C. So when you do this type of problem, try factoring the most complicated expression. In this case, we're going to note that 1 minus C squared, as we noted below, is equal to 1 minus C times 1 plus C. Now that tells us that 1 minus C squared is divisible by each of our denominators because all of our denominators are factors of it. So we have 1 minus C squared divided by 1 minus C squared is equal to 1 because anything divided by itself is 1. Now if we look at our next denominator, 1 minus C squared divided by 1 minus C is equal to 1 minus C times 1 plus C divided by 1 minus C, like we have up here, just using this identity. Now these cancel, and this is equal to 1 plus c, right? So 1 minus c squared divided is divisible by 1 minus c, and it gives us 1 plus c. And for our last denominator, just to make sure that 1 minus c squared is divisible by our last denominator, we'll just do 1 minus c squared divided by 1 plus c is equal to 1 minus c times 1 plus c divided by 1 plus c. And these cancel, which equals 1 minus c. Okay? Okay. So now we're ready to start solving because we have a way to get rid of the fractions. Because if we multiply both sides by 1 minus c squared, what's going to happen is the 1 minus c squared on this side is going to cancel with this denominator. And it's going to cancel with this denominator to give us a 1 plus c. It's going to cancel with this denominator to give us a 1 minus c. Okay? So let's rewrite the problem and we're ready to start solving this guy. So we have the original expression, which is 4c divided by 1 minus c squared is equal to c divided by 1 minus c minus 2 divided by 1 plus c. Now what I'm going to do is I'm going to multiply both sides by 1 minus c squared over 1. And I'm going to multiply this side by 1 minus c squared divided by 1. Now, on the left-hand side, we're going to have some canceling right away, which is great. The 1 minus c squared is going to cancel with the 1 minus c squared. And, excuse me again. And we're going to be left with 4c over here. And over here, we're going to use the distributive property to distribute this fraction to these two other fractions. So we're going to have 4c is going to be equal to c divided by 1 minus c times, and I'm going to rewrite this in its factored form so you can see how the canceling works, times 1 minus c times 1 plus c divided by 1 minus 2 divided by 1 plus c times 1 minus c times 1 plus c divided by 1. Now all I did, this is just 1 minus c squared. I just rewrote it using this fact, using the difference of squares formula. Okay? So the 1 minus c over here is going to cancel with the 1 minus c. And I'm going to have 4c is going to be equal to c times 1 minus c, or 1 plus c I should say, minus 2. This is going to cancel with this, times 1 minus c. And now we have a much easier problem to solve. And we're going to have 4c is equal to c plus c squared minus 2 plus 2c. So 4c is equal to c. I distribute the c over here, and distribute the c over here to get c plus c squared. 2 and a 1 give me a -2, and a -2 and a negative c. The negatives cancel, and I just wind up with 2 times c is 2c. And now I'm going to have 4c is equal to, I have a c over here and a 2c here, which gives me a 3c, plus c squared minus 2. Now, this is a quadratic, so to solve quadratics, I just bring everything over to the one side. So I'm going to subtract 4c over here, and I'm going to subtract 4c over here. And let me go on to another sheet of paper. And 4c minus 4c is 0. And negative 4c and a positive 3c leave me with 1c left. Plus c squared minus 2. Now I'm going to rewrite it. I'm just going to rewrite this as c squared as the first term. I'm going to do minus c plus 2 equals 0. So all I did was just rewrite. This is has the highest power, so I rewrote that first. The c has the second highest power, which is c to the 1, and 2 is just a constant, so I put that last. Sorry, let me put it down here so you can see, right? So I put the squared term first, the c term next, it's the next highest power, and then this has no c, so it's right like this. Now I want to solve this. Now, to know if this has a solution, since with the last homework we started working on quadratic formulas, what I'm going to do is I can solve this using quadratic formula. So first I want to check and see if there's a solution. So normally when we check if there's a solution, we write a x squared, the general form, minus bx plus c. In this case, this is just the general form equals or quadratic formula. In this case, my variable is c and not x, but this is written in the book. So there's the coefficient in front of the squared term is a 1, so my a is 1. The sorry, this should be plus bx. The coefficient in front of c is -1, so b is -1, and my constant term is 2. Excuse me for 1 second. Okay. So it's probably confusing. I have the x's and the c's here. So this is just the way it's written in the book. It uses x's and not c's. Here our variable is just c. That's the only difference. So if you line up the squared terms, the a is whatever's in front of the squared term. The b is whenever it's in front of the variable term, that's not squared, the first power, and the c value, whatever it is. Okay? Now the discriminant is going to be b squared minus 4 times a times c. Okay? Now b is, so a is equal to 1, b is equal to -1, and c is equal to 2. So b squared is going to be -1 squared minus 4 times a is 1 and c is 2, which is -1 squared is 1, and 2 times 1 is 2, 2 times -4 is -8, so this is going to be equal to -7. Okay? So normally we couldn't solve this problem, but if we allow for imaginary solutions, you can solve the problem using the stuff from section 1.4, I believe, complex numbers. We're just going to get an imaginary solution for x. Okay? So using the quadratic formula, x is equal to negative b plus or minus, because we're going to have two solutions, we're going to do 1 plus and 1 minus, the square root of the discriminant, which we already know is negative 7, which is b squared minus 4ac all over 2 times a. So I'm just going to fill everything in. So this is going to be equal to b is negative 1, so negative b is 1, plus or minus the square root. Well, b squared minus 4ac is just the discriminant, and we already know that's negative 7. Negative 7 all over 2. Well, a is 1, so 2 times a is just 2. So that's my solution, but I'm not done yet. I'm going to simplify it. The square root of negative 7, I can rewrite this problem as equal to 1 plus or minus the square root of 7 times the square root of negative 1 all over 2. And that's because negative 7 is just equal to 7 times negative 1, but I can always break apart square roots by multiplication. Well, the square root of negative 1 is the imaginary number I. So we just, as defined, there's no square root for negative 1, so we just make one up and call it I. That's what's called an imaginary number. So this is equal to 1 plus or minus the square root of 7 times I all over 2. And now I'm just going to rewrite, instead of writing plus or minus, I'm just going to write my answer separately. So what I'm going to do here is I'm going to write x is equal to 1 plus the square root of 7i all over 2. And I'm going to have x is equal to 1 minus the square root of 7i all over 2. So I have 1 plus and I have 1 minus. And those are my two solutions. I hope this helped. And just remember, if the discriminant is negative, that means that you're going to have a negative under the square root, which means you're going to have two imaginary solutions, one for the plus and one for the minus. If the discriminant, which is what's under the square root, is positive, then your square root is going to be just a regular real number, and you're going to have two real numbers, one for the plus and one for the minus. If your discriminant is 0, then the square root goes away, and you're adding and subtracting 0, which doesn't make a difference. So negative b all over 2a is going to be your one real solution. Okay, so I hope that answers the question. Since we're working with the imaginary roots and stuff like that, I extended the solution a little bit farther than we did in class. When we did it in class originally, I said there was no solution, but when you allow for imaginary numbers like we're now allowing that, then there is a solution.